Okay, class, welcome to lecture 5. Today we'll be talking about quartiles and boxplot. So this is sort of a continuation of the presentation of data lecture from last time. So the idea is that we're going to do more presentation of data, but using a different method. Another pretty common way to do this is with a boxplot. So another way to represent data is using a boxplot. You don't see this one too much in like on the internet and stuff from random people. That's because it takes a little bit more work to understand what it is, whereas a histogram, you can sort of just intuitively understand it. Even if you haven't studied stats, you probably have an idea of what it's doing. But that's also why you're more susceptible to being tricked by histograms. Okay, so in any case, so what a box plot does is it presents data, but using median-ish type things. So we'll see what that means. But in any case, it comes from using the median as the middle, or the center of the data. And then quartiles, these other things in the title, which sound very fancy, but they're not so bad. Instead of standard deviation to show spread. So the idea is that mean and standard deviation sort of go together. And when you're drawing histograms, you're thinking about the mean and the standard deviation. When you're drawing bell curves, that's going to be relevant later on. But when you're drawing a box plot, you're using the median and you're using quartiles to show spread, which we haven't learned about. So first we're going to learn about quartiles before we do box plots. Okay, so again, it's just another measure of spread. And it's not so bad. So given some data, so here's some data, 5, 12, 18, 32, 51, and 89. We define the second quartile first, not the first one. The second quartile, which people call Q, capital Q, the subscript 2. That's just the median. So they're exactly the same thing. And then the idea is that the other quartiles are defined from that one. So the first quartile is called Q sub 1. And it's a median again, but it's the median of the lower half created by splitting the data into two sides using the median. So we'll see how this works with an example. It's the median of the lower half of the data. So maybe you can guess what the third quartile is then. It's just the median of the upper half. So those are all the quartiles. Okay, so let's use our example. Now we just drew right here. So there's 6 numbers. So that means that the median is halfway between 18 and 32 because there's 2 middles. So you add them up and you cut that in half to get the median. So that'll be 50 over 2 is 25. So that is also the second quartile. So now the idea is that that quartile, or the median, cuts the data into two halves. So it cuts it into a lower half, these 3 points, and an upper half, these 3 points. So then Q1 is the median of the lower half. So what's the median? Well, we just do the same thing. We just find the literal middle data point of the lower half, and it's 12. And Q3, the third quartile, is the median of the upper half, which would be 51. That's it. So not so bad, I hope. So let's do an example, familiar example with the student score data that I've used a couple times already. So find Q1, Q2, Q3 for this student score data. So it's a bunch of data points that are just corresponding to scores that people got. Let me make them magically appear so you don't have to watch. Okay, so here's the student score data. So I believe that there's 10 data points. So that means that the median is going to be between the two middles. So let's see, I think there's 5 here, 5 data points, and then there's 5 more here. So that means that the median comes from going between these two, and that tells us Q2. So that's going to be, so I have to get the middle of these two numbers and then cut that in half, and it'll turn out to be 79.5. So that's Q2. Then that divides the data up into two halves, these 5 points and these 5 points. So since 5 is odd, calculating the median is a little bit easier of each piece. So I'll just go like that and then figure out that 71 is the middle of the lower half. So Q1 is 71. And same thing over here, make little tick marks to count towards the middle, and you get that Q3 is going to be 88. Okay, so that's it. So what do we do with this next? So we got to figure out what box plots are. So next what we do is we calculate something called the interquartile range, or the IQR, if you want to go faster. And all it is, well, it's a range. So the range is just the biggest thing minus the smallest thing. In this case, it's the biggest quartile minus the smallest quartile. So it's Q3 minus Q1. And this measures spread in a way, because it measures how far apart the middle 50% of the data is. So think about that for a second. So to measure it, so the IQR, sorry, next we calculate the IQR to measure spread, because by definition, what's going on is that it contains 50% of the data. So it contains a good chunk of the data automatically just by definition of medians. So we can see that here, that this will always happen. So if I go from here to here, from Q3 to Q1, there's always going to be 50% of the data in there, no matter what. So if I go from here to here as well, always contains a bunch of data. Okay. So in this case, let's calculate the IQR for this example. So it would be 88 minus 71, which is 16. So what's good about the IQR for measuring spread? Well, since it's based on the median, not the mean, then it doesn't easily get influenced by very big points that are far away, or very small points that are far away in the other direction. Okay, so since it's based on the median, another way to say it is that it is not easily swayed by far away data points. And then, so why is this good compared to the standard deviation? Well, the standard deviation uses all the data points to calculate a measurement of spread. So if you have very far away things, your standard deviation can get sort of screwed up by very far away things, but your IQR won't necessarily, because it comes from using the median. Okay, and so for that reason, we use the IQR to determine outliers. So that's a word that was in the title of the last lecture, but I didn't use it. So now we're going to talk about outliers. Okay, so due to this fact, we use IQR to spot outliers, which are data points that are too far away. And again, we can't use the standard deviation to figure out outliers because they are impacted by the outliers. The standard deviation is impacted by the outliers. So you can't, it's like trying to measure a ruler with the ruler. It's just not going to work. Okay. You need a second ruler that doesn't get impacted by the first ruler. Okay, so that's what's going on here. All right, so how do we actually spot outliers? First, we're going to find Q1 and Q3, which comes already earlier. And then we're going to find the IQR, which again, we already did earlier. And now we have to do something different. We have to calculate or determine something called a fence. So we're going to determine these fences. So the idea is just like a real life fence. It sort of creates a little border that says things are too far away or not. And this is what helps us determine outliers. So if you can get the lower fence and the upper fence, doesn't matter what order you do it in. But the idea is one is a lower bound and the other is an upper bound. So the lower fence comes from saying, okay, Q1, that's pretty far to the left, but my outliers can go a bit further. How much further? Well, this is a bit sort of subjective, but somebody decided a long time ago, I guess, that 1.5 times your IQR, that's too far. If you go past that, then you're an outlier. Similarly, if you go too far to the right, so you go past Q3 plus how much? Plus 1.5 times the IQR. If you go past by that much, then that's too far and you're an outlier. That's the idea. Okay, so then the data not within the fences are the outliers. Okay, so let's do some examples. So for the student data above that we used already, we already can do all this because we know Q1 is 71, Q3 is 88, and the IQR was 16. So then we can create these fences. So the lower fence is saying that 71 is pretty low, but outliers, they can go a little bit further. How much? Well, they can go 1.5 times 16 more. So what you're going to do is you're going to multiply these first, then you're going to do the subtraction. And when you do that, you'll end up with 47. the upper fence, same idea, 88, but now how much further above 88 can you go? Well, that same amount. So if you add this, you get 112. I think this is just 24, right? 125 times 16. Yeah, that's 24. So what you're doing is you're subtracting 24 and you're adding 24. Okay, from the lower and the upper fence. Good. So now if I look back at that data, way up here, the idea is that my two fences are, what were they? I can't remember, but 47 and 112. So none of the data goes past that in either direction. So there are no outliers because nothing is past the two fences. Okay. So none of the data was past it. So there are no outliers. Okay. So next, we're going to use all this stuff to create the box plot. All right. So that's what's next. And when do I want to say this? No, okay. All right, so to create a box plot, we need something called the 5-number summary. Stats people, they just love naming things that don't need to be named. I don't know, this doesn't need a name. But in any case, it's just 5 numbers that you need to get from your data. Okay, so we'll just do it by example. So let me pop this data in real quick. Boom. Okay, there it is. All right, so what's this 5-number summary business? Well, it's just the minimum, which is the smallest number, the maximum, which is the biggest number, and the 3 quartiles. So that's the 5-number summary. So you find your 5-number summary for your data. So what's the minimum? 2, because it's the smallest number, and I've already ordered it for you. The biggest number is 95. Okay, quartiles. So find the second quartile first by counting. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So it's going to be cut into 5 pieces. So the median, or Q2, is going to be in the halfway between 35 and 36, which is 35.5. Then I'm going to look at the upper half and the lower half separately and find their medians. So that's going to be 50 up there and 25 down here. Okay, so 25 and 50, good. So that's step 1 to making a box plot. Get these 5 numbers. Okay, so then we're going to draw a number line that sure, sorry, I skipped a couple steps. Okay, no, we're not going to draw a number line yet. We're not there. Okay, so next we're going to get the IQR. So remember that's quartile 3 minus quartile 1. So 50 minus 25. And that's going to also be 25. And then we're going to get the fences, upper fence. So I'm going to take my 50, I'm going to add 1.5 times my IQR, and my lower fence, doesn't matter which order you do these in. So I switched them up this time to trick you. I'm going to take 25, I'm going to subtract 1.5 times 25. Okay, so you do these real quick. You'll get 87.5 for the upper, and you'll get negative 12.5 for the lower. Okay, now we can draw a number line. That's the next step. Okay, so next step is draw an appropriate, so it's kind of subjective, number line. So the idea is that your number line, your box plot is going to go above the number line here. And I'm going to go from 0 to 100 because if I look at the data, that's about where it goes from and to 2 to 95. And then I'm going to count in intervals of 10 because you don't want it to be too small or too big. So that seems just right. So 10, 20, 30, 40, 50, 60, 70, whoops, I need more room. 80, 90, 100. So this will be 20, 40, 60, 80. Okay, good. So that's the next step is the number line. Okay, so this is the beginning of the box plot steps. So next we're going to draw vertical lines at Q1, Q2, and Q3. So the idea is that these three vertical lines will give us sort of a box that contains 50% of the data. So 25 is Q1, so I go to 25 and I just sort of try my best to find 25. I draw a vertical line there. And that's good, yeah. Okay, and then I go to Q2, 35.5. So what would that be? Around here. And then I go to 50 for Q3. So then I turn these three lines into a box. Hence the name Boxplot. So there's the box. And the idea is that it contains 50% of the data. It's cut in half. So half of that 50% is above the middle, half of it's below. That's just because of how the medians work. So next, we are going to draw the rest of it. So we're going to draw a line from the box to, so people always get this step wrong. I don't know why, but try not to. Okay, so we're going to draw a line from the box to, not the smallest data point, but the smallest data point above the lower fence. So still within the fence. So what that means is I have to go and I have to look at my data and I have to look at my fence and I have to say my lower fence is negative 12.5. What is the lowest data point still within the fence? Well, it's just 2 because 2 is the lowest data and it's still within the fence. So in this case, it's 2. So I'm going to draw a line from the box down to 2. You can just estimate. Okay, and now we're going to draw another line going the other way. So draw a line from box to the biggest data point. Again, still within the fence. Within the fence. So I go and I say, what's my fence? My upper fence is 87.5. So I go up here and I say, what's the biggest number still within? Well, 95, that's too big. It's not in the fence. It's above this fence of 80, what was it, 87.5? So it's too big, it's above the fence. So I have to go lower and I say, oh, okay, for 51, That's still within the fence. That's okay. So in this case, that's 51. So my box goes over to 51. So it looks very puny, just looks like this. Okay. And then the last thing is to plot the outliers. So this is where the outliers come in. So as little stars. So the way this works is I look and I see what things are beyond the fences in either direction. So only 95 is an outlier because it's the only number above or below the fence. So I go to 95, right around here, I guess, and I put a little star there. Happy little star. Okay, and that's it. That's the box plot. Not so bad so far. So let's do one more example with the student score data that I used a bunch of times already, since I've already calculated a bunch of stuff about it. So I won't rewrite it here. I'll just go quickly. So the minimum, you can scroll back and start from scratch if you want to. So the minimum is 62. The max is 95. So notice that these two numbers aren't even part of the graph, really. They don't really do anything to help you. But for some reason, we write them down because they're part of the 5-number summary. Okay, we had Q1 was 71. We had Q2 was 79.5. And we had Q3 was 88. We had the IQR, that was 16. We had the upper and lower fences. The lower fence was 47. The upper one was 112. So remember, there were no outliers. So what that means is our box is just going to stretch all the way to the top and the bottom, but that's not what has to happen. Okay, so this time I went from 55 and I counted by fives. So 60, 65, 70, 75, 80, 85, 90 to 95. Okay, so I draw vertical lines at the quartiles. So let's see, 71, just sort of estimate your best, 79.5, and 88. That turns into a box. So now I go to the lowest point still within the data. Well, that's just going to be 62. Because the fence is so low. Still in the fence. The lower fence goes all the way to 47, so all the data is within that anyway. So I just go to the lowest point, but that doesn't have to happen usually. And then for the upper fence, I go to 95 because it's the biggest data point in the fence. And there's no outliers. So I don't get to draw any little stars. Okay, but the other example is probably a better example to practice with because you didn't just go to the minimum and the maximum. Instead, you go to the biggest point, still within the data, still within the fences, and the lowest data, still within the fences too. Okay, so I'm going to summarize because this is sort of like the end of the section. So what we have are measures of center. So this is the mean and the median and sort of the mode. It's in here a little bit. We have the measures of spread. So we have lots of these: range, the absolute mean deviation, the standard deviation. So those three sort of go with, I guess I forgot variance too. So those four, well, I guess range doesn't, but these ones here they sort of go with the mean because they come from the mean. And what that means is that they're very liable to changing by a lot if you have very far away data points. And then what we did today was the IQR, which is much more robust. Doesn't get swayed so easily by far away data points because it's based on the medians. And then we have measures of position, but we only did one thing for that, and that was the z-score. And again, that sort of goes with the mean and the standard deviation. And then lastly, we have measures of outliers. And for those, we use the fences. And those are a median-ish type thing. Because if you want to know which things are too far spread away from the middle, you have to use the median and the IQR to figure that out, because they will not be swayed by the faraway things in the first place. So the standard deviation would be too big because of the faraway things. And so it wouldn't ever tell you that those things are too far away. Okay, so that is it for today's lecture. See you next time.